It's so actually good to see so many faces of familiar names in the chat. Welcome. So today we're introducing a new major improvement for how we do deployments of Kubernetes with Octopus, and this is our new agent. The agent is here to complement, because we're actually not going to replace the old way of doing this. Basically, become another way to set a target, a Kubernetes target in Octopus. And within this, through this webinar, we'll talk about why and how you can use it. But before we begin, who we actually are. So we have Alastair here. Alastair is the lead engineer from our team. He's been leading this project since the very beginning, and we'll show you how it's done and actually do a bit of a demo. And I'm Kit. I'm a product manager, again, been on this project from the beginning, and I will walk you through all the reasoning and good things about the agent. So, who is this for? Mostly it's for people who use Octopus and use Kubernetes. You don't need to be an expert in either of this, as well as you need to be an expert in Octopus. So consider that being useful for anyone from entry, mid-level Kubernetes and Octopus experience. All right. So what we're doing again, I'll explain why we have Kubernetes agent developed. I'll show us how it works behind the scenes, give us the demo, and then we'll talk about some next steps where we actually need your feedback that will really help us to build the next thing. All right, so Kubernetes agent is meant to solve a few problems. So we'll walk through all of them and maybe have a bit of a discussion. So first of all, and the main thing we heard about the existing target is that it's not always easy to install, because you need to get some credentials to the cluster. You need to understand how all these fields work. With agent, it's very, very simple. So the only thing you need to do to install the agent is actually to copy Helm command, put it in the CLI, press enter. That's it. So you can do all the fine tuning. The command is on your screen, so you can change permission, you can change namespace. But in general, if you do nothing of that and just copy paste and click enter, your agent will be there and your target will be registered in Octopus. So no extra effort is required. However, if you want to go at scale and, for example, install hundreds of clusters with agents, or maybe you want to add a new cluster every day, you can just use something like Terraform, and the agent installation will be fully automated and can become just a part of your cluster bootstrapping. Basically, as soon as you have a new cluster, you can have an agent there, and it will be registered in Octopus just automatically by default. So this is the first problem the agent is solving. The second problem we wanted to solve is how you can actually access the cluster. And before, when we had the API, we usually had an issue where people have to choose the way to authenticate to the cluster, and then eventually they have to come with the idea how they rotate the secrets or like credentials or certificates, whatever it is. It adds extra load on the administrative maintenance, especially if you have hundreds of these. So again, with agent, there is no need. Agent lives within the cluster. It's just a couple of pods running in a dedicated namespace. So working from within, it does require any of this. So you can just literally forget about all the secrets and credentials, which actually makes it a bit safer too. The next one is simplifying the network connectivity. So as you may know, if you want to deploy to Kubernetes with Octopus, you need worker. You need something to execute the deployment, connect to the cluster through the API, and talk to the basically sending commands towards Kubernetes. This is fine, but it creates an extra need. It basically requires you to give worker access to the cluster from the outside. In many cases, it means adding another exceptions in the firewall, allowing the external connection, and maybe for some people it's just unacceptable or too hard to manage. So again, with agent, there is no need in that, because agent is working from within the cluster, and it actually establishes a connection back to the server. So for most cases, for most clusters, you will be able to, clusters are able to established connection from within. So in many cases, you just don't need to do anything else after you install the agent. Finally, and this is arguably one of the biggest things here, is tooling and workload deployment. Let's start with workload deployment. What does it mean? As you know, most of the time you need workers to install something on Kubernetes, and that's because you need a place to execute command. Agent is actually acts as a worker. So agent can run commands, deployment commands, scripts, Helm, customize, kubectl on the cluster itself. So for this purpose, we create like separate pods. Therefore, Octopus server just talks to the agent, gives it a deployment task, and agent does all the work inside the cluster. So you don't need to worry about workers, you don't need to install them, you don't need to update them, you don't need to think about scaling them. Cluster will scale it for you. So you want to run 1,000, 150 deployments against this cluster, the agent will, generally speaking, do that because it can just create as many pods as the cluster allows. Another consequence of this is, in many cases, except when you're working with the script, you actually don't need to think about tooling. The agent knows what cluster it's running on. We can scan the Kubernetes version, and therefore, for building steps like customize Helm YAML, agent will just choose the right execution container. So you can forget about, like on the screenshot here, you can forget about choosing running directly in the worker or inside a container. We'll literally just remove this fields from the step configuration for the agent. And finally, which might be a good surprise, there is no need to migrate. So if you have a process and a project set in Octopus, and you already have your the roles configured and your environments configured, you can just add the agent, give it the same environment and role, and press deploy button. So Octopus will do exactly the same. No need to change your steps. It will just deploy to the cluster, and that's it. So you don't need to go back and change your project. You don't need to do anything with variables. So literally just add the agent, and that will work. And before we go forward, what do you have? Yes, Al, it might be for you. What's the pooling interval, and is it customizable?
That's a great question, actually. I think the polling interval is it's at least every. It's quite a fine resolution. I'm not actually, to be honest, I'm not actually sure off the top of my head. It's I was going to talk about it in our next slide, but it's built on our Halibut GRP or RPC framework. I'm not actually sure what the polling. It's quick. It's not like on the minute. We're not in the or talking on the order of minutes here. We're talking about like seconds. So it's not a slow poll or anything like that. But it is tunable, I believe. I'll have to investigate. That's a good question.
Thank you. And the next one was, is the agent pooling only or can be set to listening? It is now pooling only. We're considering if we should add the listening option, and that's actually one of the things why we need your feedback.
Yeah, because as I mentioned, it's built on Halibut, which supports both polling and listening. For those that aren't familiar, listening is reaching out. So Octopus server would reach out to the agent. We do technically support that. We haven't built it in because that's not our first priority. There's and it has the same problem that we kind of currently do with our current API target, which is you need to publicly expose your Kubernetes service. You'll need or Kubernetes cluster. You'll need to create a service to be allow the port to be forwarded out. But we can certainly see certain customers will have that as an option that they would like in certain circumstances. So we want to offer it. We just haven't done it for our very initial release.
Yeah, we have a few ideas for step 2, and that's actually where some voting comments would be really helpful. I see a few more questions, but I guess the next few slides will answer them. So I hand over to Elle.
Excellent, thank you. So I apologize, my screen is a little bit funky at the minute, so I can't actually see what the slides are. I can see them, what slide we're up to. Can you please take me to the built on tentacle slide? And
Yes.
I know where I am. Excellent. So I'm just going to talk about how it works. And just to kind of, so a little bit of technical information for those that are familiar, kind of with some Octopus concepts before, and then some kind of just general kind of Kubernetes things, just to explain what the agent is. So fundamentally, the agent is a Helm chart. So we think of the agent as the Helm chart, the thing that you install via Helm, but that's made up of a couple of components. The main component is an Octopus tentacle that is running inside the cluster. So the tentacle, for those that aren't familiar, is kind of a headless agent that was used primarily for VM deployments and workers. So it's been a piece of code that has been around for a very long time. So we've basically built upon that and leveraged it, and then gone from there to make it more specific to Kubernetes. So as I mentioned earlier, it has the Halibut RBAC protocol for communication, so that supports listening and polling. And those connections are TLS secured. So within the cluster, what we'd have is what we call our long-running, it's an agent container or the tentacle container. And then each deployment that occurs is a individual short-lived pod that we spin up. We have the correct tooling with that, and then we tear it down at the end of the script effectively, which is what most deployments are. This gives us the ability to scale that work across the cluster, because the work doesn't need to be performed within the tentacle container itself, and therefore it doesn't also need to be run on the node that the tentacle container is run on. So it can be, so if you've got a lot of deployments, they can then be scaled across the entire cluster itself, rather than kind of being concentrated on a single node within a single pod. And one of the advantages of this is, one, because we're installing via Helm chart, is we can do, and it connects to Octopus Deploy, we can do all the automated updates through Octopus Deploy. And because the agent itself is deployed via Helm, we can actually have the agent update itself by running a script to update itself. So it's got quite a nice little feedback loop there, where we're kind of being inside the cluster. For those that aren't familiar, being inside the cluster means you get kind of an in-cluster configuration, use the service account of the pod, means we can just run the Helm command and Kubernetes will tear down Tentacle, make the upgrade, and then bring it back up, and Octopus Deploy will just see it be the new version once it's, Kubernetes has done its work. Next slide, please. So out of the box, we have two support. So part of the tentacle thing is, we do need access to kind of a file system, because there's things that Octopus Deploy sends to tentacle as part of the deployment. You might have packaged up your YAML manifests in a in a zip file, or your Helm chart that you're deploying gets sent to the agent to do the deployment. And then obviously we need to share that with the scripts pod. So out of the box, there's kind of a zero conf or zero configuration NFS, where we actually run a small NFS server next to the tentacle, and that then provides the shared communication between the script pods and tentacle, so we can have access to kind of that shared file system. So you don't need to kind of configure in that scenario, which is our default, and you'll see that you don't need to pre-configure persistent volume storage. And it's also quite performant, because it's actually all within the cluster itself, we've found, which is quite nice. Now, it itself, being its own pod, does have some reliability, I wouldn't say concerns, but it has some reliability trade-offs, right? Because it is the NFS server itself is actually a pod. It therefore has to run, it can, Kubernetes can tear it down and move it around as is its need. So in that particular case, we do offer the ability to say, well, no, we have pre-configured persistent storage or persistent volumes, and therefore use that instead of the NFS, and then that would just disable the NFS server. So we kind of have two options there. Next slide, please. In terms of permission, so we now have a thing running in, we now have an agent running in your cluster. We do our deployment. What does that deploy as? What permissions are we doing that in? So by default, we kind of have this permission structure of, the very first option is, or the default option is, we kind of have a cluster admin. So each pod that we spin up, now the actual tentacle pod doesn't have these permissions. It's the script, what we call our script pods, the things that are actually doing the deployments. Because Octopus could be you could be doing multiple deployments to multiple different namespaces, and we're not at the point of deployment. We don't actually know that information when we're setting up that. So by default, we kind of have a cluster admin wide permission structure where it can just deploy to any namespace. Now, that's not going to work for everyone, but it's a good out of the box. We can also then, as part of the Helm chart, you can say, well, no, I know that I only want to target these specific namespaces, and we will change that from a cluster role binding to a role binding, where the script pods will only be able to deploy to the namespaces you have specified. So giving you that kind of granularity in that particular case. And something we're considering, and this is something that Kit will talk about a little bit later, is the idea of, well, what if I want the permissions to change based upon whether it's an environment or the tenant coming from Octopus? So there's a scenario here where you may need, inside of Octopus, you may want to define like service accounts, or you may want to define a relationship with a Kubernetes service account to a particular environment or a tenant or a project, so that when we do the deployment, it uses that specific kind of bound service account rather than kind of a single service account, which is the first two options. So that's kind of how it generally works. It works very much like a normal deployment thing, and we're going to do a demo right now. I'll show you the process of.
Should we maybe answer a few questions before we jump into that? While we're
Yes.
still on the technical side.
Yes. Sorry.
So one of them here is: are agents unique to each space? And what if I have two spaces that need to talk to the same cluster?
So, and agents are unique to spaces because they are considered infrastructure. So you would have to have, in that particular case, two agents installed, which is totally fine. You can have multiple agents installed, as many as you, effectively as many as you want. Now, this is the caveat: is it depends on the size of your cluster, and gives you that kind of, so obviously if you've got a small cluster or a small number of nodes, and the more things you put in it, obviously CPU limiting and memory limiting is going to occur. So
we actually had this question first time last week. I mean, from the customer, and if it's a biggish concern and it's common to have multiple spaces going to the same cluster, let us know, because again, this might be an improvement which you can add as like step 2. Can there be multiple agents on a cluster? For example, we currently have a separate target for each application namespace that may be in a single cluster. Yes, you can definitely do that. Will it require more CPU and RAM, and we just have a few things running on the cluster in parallel? Yes, it will. So we'll talk about if you need that, and well, if it's required to give more granular permissions within one agent, so you won't have to do that. But if you want this, yes, you definitely can. What are the RBAC environments requirements on the cluster to install the Helm chart?
So you need to be able to create a namespace, or obviously put it into a known namespace. Our default, and you'll see this in a minute, our default Helm chart basically will create the namespace for you. So our current position is you kind of just need a cluster admin thing. Now, we do support, as I think Kit mentioned earlier, we do support, you could install the agent by Terraform. So you could, as part of scripting up, say, like a new cluster, you could then, and you could use the Helm. There's a Terraform Helm provider. There is an Octopus provider, so you can also then, set all of that up there and then install it that way. But right now, you kind of need to have enough permissions to be able to create resources either within a known namespace, or enough permissions to create it and create the namespace at the same time, which is kind of our default settings for the installation Helm command.
Then Ryan also asked, can the agent be used to execute non-Kubernetes deployment steps? Yes, we have it so many times. We have it so many times that yes, we'll do that. So yes. As soon as we release the agent and we get some first early feedback that it's actually working, this is definitely on the list. We are thinking about this. We don't know yet when, because again, we need to release the agent and get some feedback and ensure it's stable. But as soon as we pass this point, yes, we have this on our minds. We are thinking about making this more like a scalable worker pool in Octopus.
Yeah, fundamentally, we're using the exact same technologies that our workers use. So there's no reason that we can't leverage the cluster itself and have it manifest as a worker pool, within Octopus, and it's just a cluster and it scales as your cluster scales.
Yeah, there will be maybe some extra requirements security-wise and storage-wise, but we'll figure it out. Are Windows nodes supported?
No, not currently. And right now we have no short-term plans for supporting Windows nodes. Where, please give us feedback on this, in our discussions and our user interviews and things. We just haven't had the necessary pull to put the time into it, to be honest.
Finally, can we keep the configuration of agents through JSON, YAML, AC, etc.?
Not sure I understand the question. Sorry.
I mean, can we, I guess, and correct me if I'm wrong, I understand that as can we have it not as Helm, but as a bunch of YAML files, for example?
Oh, okay. So yes. So rather than a pure Helm command, so we don't offer it. But I guess right now, I guess that would be something that if customers really felt that's the way they want to do it, we could certainly do that. It would it's almost like a deconstructed Helm command, I guess. We have quite a number of, and our Helm, for what it's worth, our Helm repository, the Helm chart repository is public. So, we would certainly, once we're released, accept pull requests and feedback and issues and things in that. But yeah, we could do it, but right now we're not offering it. It's more just we're starting off with Helm, and then I guess we'll see what the feedback is and what customers are looking for and how they want it to work.
And you can, I guess, even now just use Helm template, and you actually have YAML file which you can later use and modify as you wish, right? So after all, there are no limits. Right, so maybe let's jump at the demo. We have 3 more good questions, but I guess they will require more time and we'll answer them after the demo.
Okay, sure. Excellent. So on my screen right now, I have a pre-configured Octopus project that is doing some Kubernetes customized deployment. So we'll go into our process here. So deploy with customize. So I'm just deploying to an AKS instance that I've already set up. And I'm using our Git sourcing to pull the YAML or the customized overlays directly out of Git. And I've currently deployed them using a Kubernetes API target. So our existing target, because part of the process is, as Kip mentioned, is a very easy migration path, right? We don't need you to do anything, and we don't want you to change your process to have you be able to deploy with the agent. So we're going to show you that. So now when we go to our infrastructure tab and we go to our deployment targets and go add, so you can see this is our existing API target here. I'll go to add deployment targets, and under Kubernetes, we now have this new Kubernetes agent option. And when we do that, it prompts you with this nice little wizard. So we're going to pop in we'll go webinar demo. So like most deployment targets, you pick your environments that you want that to manifest in. We're going to pick the exact same role that our existing target has, so that we can then just disable the other target and deploy using the exact same one. We have some advanced options, so you can do things like set your default Kubernetes namespace. So if your manifests don't have a default, don't have namespaces set, which is something that sometimes happens, and we certainly see, you can put in a default one here, and that's what will get used if you don't specify it in the actual step itself. And then, as I mentioned earlier, you can use your own persistent volume storage, and clicking this option will add an option into the wizard, which will then allow you to configure that, provide us with a storage class name. So I'm just going to pop in a little demo thing here, and we'll go next. So as I mentioned, we use by default an NFS pod to do that. There's some limitations in Kubernetes itself around NFS and domain name resolution, which was a bit frustrating. So one thing we do require you to install a CSI driver, CSI being container storage interface, I believe it is, which basically is it's just a thing that's been developed by a Kubernetes SIG group, which is basically allows you to do certain extra bits on top of it. It's like extra functionality for NFS within that. So I've already installed this into my cluster, but that is a requirement to install as part of the Helm, as part of the using the NFS. Now, if you choose to use your own PV, you don't need to do this step. This changes and says, hey, would you like to give us the storage class name that you would like to choose? So now we get to installing the Kubernetes agent. So this is our Helm command. We offer Bash and PowerShell kind of options for this. And it comes with all the pre-configured things. So if you're on a cloud instance, which it will set up, pre-configure all these server URLs. If you're self-hosting this, there are actually options that you would set back in the advanced section. And it comes with all the settings that we've set up there. So I will go to PowerShell and I'll copy this because I'm on Windows. And we've already started looking for the target. So right now, we are trying to search for the target. So what I'm going to do is I'm going to open up my thing here. And I'm going to paste in my big Helm command. And we're going to hit enter. And what this is going to do, this is going to install it into our cluster. It's going to, so we're hosting our our Helm on the Docker Hub OCI registry. And that's going to then get pulled down and installed into our cluster. And this usually takes, because I haven't run it into this cluster before, it's already cached the images, but sometimes this can take a minute or two, or depending on how my cluster is behaving today. So the Helm command, as I mentioned, I'll just, while this is talking, or while this is going, the Helm command, these aren't all the options that are a part of the Helm command. These are just the minimum required effectively to get it up and working. We will have a kind of a documented values.yaml file. We don't link it from here. Fantastic, it's finished. I'll finish my point. And then you would actually be able to run this command yourself if you wished. For those that might have seen, there is a bearer token in here. So that's a 1 hour short-lived bearer token, so the agent can register itself with Octopus. But you can change that to be a long-lived server API key. So in kind of automation scenarios where you're doing it via Terraform, or you're doing it via maybe like just other scripting processes, that can just be a server API key that you've set up in Octopus and lives for as long as you need it to. And in that case, you would just do the same thing. All right, so we have installed our thing, and now it is moved on to performing a health check. So the first thing that we always do when we're doing our targets is we're looking to see, it checks to see if the agent is correctly working. And I'm just checking to make sure that this is behaving. Excellent. So now it's going to do a number of health checks. So it basically runs a number of initial scripts to make sure that everything is behaving correctly. And I think it might actually be, what is this thing doing? My cluster is deciding it needs to pull the worker image, even though I pulled it yesterday. So I'm just going to give this a second while that is carrying on. We can actually move on from now, so we don't actually need it to wait for that to occur. But this should go green in a minute because this is just finishing its, there it goes. Excellent. So we have successfully registered and it is now run a health check. So a health check is kind of an important step because it shows that we can actually pull images and run scripts. So it's a good kind of validation for that. We have all of our settings. So while in the Helm command, we have a number of initial settings, you still configure the settings after the fact inside of Octopus. So if you need to change the environments, if you need to change the target roles, change the machine policy, all these different bits and pieces, you do that from inside of Octopus. You don't have to rerun the Helm command to do it. So what we're going to do now is we're going to go to our infrastructure. So we're going to disable our Kubernetes API target. And we're just going to go straight to our project. We're going to create a new release. And we're going to deploy it. And that will start deploying. So you can see now we're using our webinar demo deployment target as opposed to the previous API one. For those that haven't seen it, this is the updated, there's a blog post about this, but this is our updated task log UI that has had a fairly major UI and functionality refresh, including the ability to copy and paste, copy in a nice format finally. So when you the very first deployment to your agent, we need to extract the calamari tool, and that was actually what that always needs to occur. But from now on, it'll be cached on the tentacle on the agent itself. We're now uploading our YAML files, so downloaded from Git. They get packaged up in Octopus and sent over. And now we're going to do the deployment directly into our agent or into the cluster directly via our agent. And all the features that worked previously continue to work. So I think the Kubernetes object status, for those that aren't familiar with this is some functionality we added, I think 1 or 2 versions ago, which as part of the deployment, we monitor the resources that you are deploying, and the deployment is only considered green and successful when when all of your resources are running and green. So this is a little bit of a wonky demo because my resources are actually already running. This is going to kind of appear and be successful very quickly because it's not, they're already. It's basically just checking to make sure that they are the correct thing. So under our verbose logs, you can actually can know that we're running under in pods because we do log out when pods start and when pods complete. So we do have some of that little bit of extra information so that if you do need to go through and do either checks or identify if there's maybe a pod got stuck or maybe it got moved to a different node, the node died, and you'll be able to identify some of that information and hopefully use that if there's errors or problems like that. So we'll go back to our Kubernetes object status, and hopefully this will appear in a second as the script runs. So as Kit mentioned, we don't have you don't need to provide things like execution containers or tooling anymore in the process. It will just automatically use them because we already have a pre-built container image that contains Helm and kubectl and we have a number of versions, so we can match the version of those tooling based upon the cluster that we're installing into. If you're running a Kubernetes script step, you can still provide your own images. That includes private image registries, and we will set that up inside the cluster, pull that image using the credentials you provide, and then we will be able to do the deployment within the context of your thing. It's a bit of an advantage. Technically, you could actually run our tentacle right now inside of Kubernetes, but you need to provide things like a privileged container because you might need to run Docker in Docker. This, by leveraging the native Kubernetes workloads, we don't need to do things like that. And bear with me, I'm just seeing why this script is running. There it goes. Excellent. Always the way you look at something and then it appears. So this is the Kubernetes object. As I mentioned, it kind of appears because everything was starting immediately as opposed to, everything was already running. So it's kind of like validating everything and then everything is done in the first pass. Whereas if you're deploying things for the first time, things appear and then it takes a bit, obviously things spin up and stuff like that. And the deployment is finished. So we have successfully done that. So that's the kind of the demo of the process, the installation of the agent, and then we've seen how we can just disable existing targets and to run the deployments as long as they're in the same target role, that it will just continue to work. Just for what it's worth, the removal of the agent, we provide if you do need to remove it, as part of the deletion here, we do provide the correct commands to remove it. So we obviously need you to uninstall via Helm and then do a namespace delete. So that making sure that information. So because obviously we have things running in your cluster, we need to give you those options to know how to uninstall that. So And that's the demo.
We have a few great questions about tooling and containers, which I
Yes.
guess we'd better answer now because it just fits the discussion well. So first, Laurie asked, I run most of my deployment steps in a custom container that has tools like psql installed. Will I still be able to do that?
Absolutely. Yes, you will. So the execution, as I mentioned, strictly speaking, we don't need the execution containers to do deployments. But if you want to specify them or your existing configuration uses them, we will respect them. And as I mentioned, that also supports private repositories or registries. So if you've got a private, Azure Container Registry or whatever the Google Container Registry one is, and have credentials for that, that will set up that secret inside of the cluster, and then it will pull using that secret. So yes, absolutely.
Can we run agents with custom images?
If we're talking about the same thing there, yes. I'm not sure.
I mean, you can't replace the agent image itself because this is our tentacle container, but you can run your step, a script step, with your custom worker, with the custom execution container.
Correct.
And someone else was asking, yeah, is it like, does this mean we cannot use custom containers anymore if we're using the agent to deploy? I guess you can. So that's, yes, you can.
Yeah.
Mark said, I was hoping this would essentially let us spin up dynamic workers in Kubernetes. Yes, if these workers are for Kubernetes, yes, agent will act as a dynamic worker for this particular target, and yes, for any other targets, but just a bit later as the step 2.
Yeah.
So kind of yes for both, for Kubernetes right now, for other targets, probably a bit later.
Yep.
Well.
No, I was just, yep, all good.
Okay. Your default workers, will they be migrated to Kubernetes agent? Not migrated, so we'll definitely keep the current workers available for like whatever reason, right? And you can run Tentacle as a container in anything like literally like any platform running containers, or you can run it on VM. That will still happen. Sorry, Al?
I can probably I can give an answer on that one. So for our cloud dynamic workers, the answer is going to be no. It's actually a security boundary. Recommendations and not feedback, but basically Microsoft and others have said that a container image is not a security boundary. The underlying virtual machine is the security boundary, and as we're hosting people's workloads and they could be running any scripts. We can't have dynamic workers running in the same cluster for different customers, right? Multi-tenancy things. So there is things like Kata, for what it's worth, there is things like Kata containers, which are slightly different, which would possibly provide that isolation. But yeah, we spoke to our cloud team about this when we first got out, and there's security concerns about replacing that. Now, if you're a customer or you yourself are running your own cluster as a customer, that's not a concern, right? You're not running multi-tenanted things. The scripts you're running inside of your cluster. For us, it would be a concern of multiple customers are running multiple scripts in the same cluster, and there's ways to break out of that isolation box, which is obviously a problem. So
yeah, but I mean, if you want to run it with your cloud instance on your cluster,
absolutely.
You can absolutely do that. You manage the bootstrapping step of loading the agent mainly using a credential to access the cluster. Can this be automated as a part of the cluster build step using Terraform or similar?
Yeah, so yes. So as I mentioned, really, we do need an Octopus. So the agent, the way it works is when the agent starts up for the first time, it registers itself it calls back into Octopus and registers itself and provides things like the SSL thumbprint. So it says, this is my security certificate. And so the SSL exchange can occur, or the TLS exchange, I should say. But you can do that as part of Terraform. So, you do need to at least know, if you're bootstrapping your cluster via, Terraform or Bicep or some other thing, you do at least need to know, okay, this is my Octopus thing. If it's a Octopus cloud, obviously you've got a URL. We have our polling URL there. And you just need to provide a server API key in that particular case. As I mentioned, when you do it through the UI, we have our short-lived bearer tokens, but that was very much to stop people having to create API keys every time they want to install one of these things. But if you're doing kind of an automation scenario, you would just go in, create yourself an API key that has the lengths and the permissions you need, and then you would, with a service account, and then you would set it up that way.
And we are now writing docs, and we'll have a separate doc just for this scenario, literally like how to install agent as a cluster bootstrapping with Terraform. So we know it's a big scenario for many people. Finally, will it work on my self-hosted Octo server? What will the cost be? It will. I mean, agent is for Kubernetes. So if you want to deploy to the Kubernetes and you run your Octo server on the Kubernetes, you can install the agent on the same server. And actually, of course, you can install the agents to work with any on-prem Octo server without any issues. So it doesn't matter if it's a cloud server or on-prem server, the agent will work with either. And you are not paying for the agent itself. I mean, it will consume some RAM. I think it's about 200 meg. Correct me if I'm wrong, Al. In the idle mode.
It's quite lightweight. It's not doing whole. It's typically idles at less than 100 mega RAM and very small milli CPUs.
And then if you want to deploy, of course, it would consume a bit more resources during deployment time, running these extra pods, but that's it. So the running cost is pretty slim. And finally, Mil asks, can you confirm we can have namespace isolation with dedicated namespaces agent scope to the same namespace and scale the setup?
So you can have multiple installed. They'll be in different namespaces, and you then, as I mentioned earlier, you can scope a particular agent to only deploy to specific namespaces. We don't currently support replicating. So this is just a little bit off the end of that. Is replicating setting kind of a replica count for the tentacle or the agent itself. We haven't quite got there yet. There's a few kind of stateful parts of that code base we're still working through, but we're hoping that will be available. So you would actually, you could set that replica count to 1 or 2 or 3, depending on your nodes, to kind of give you a bit more, throughput, because each of those replicas would open an extra connection to Octopus server. So you can kind of distribute the work that way, but also obviously a bit of resiliency, right? You can, if a node has to be, upgraded or goes bad or whatever like that, at least you still have existing line rating. So we should have that ready for EAP, but we're working on that.
Finally, Laurie, I'm pretty certain there are no extra licenses for the Kubernetes agent. So I think it should be fine.
Yeah, not that I'm aware of.
Okay, thanks for the questions. And we have a few more slides to show. And actually, that's where we ask questions from you. And we actually need your help. The thing is, the agent is early access. We are just finishing this, literally like running some polishing tests and writing docs right now. And we need your help to, first of all, get feedback on the agent, but second of all, understand where to steer this development next. Because it's not like we're going to release the early access and then do nothing. We actually intend to keep working on this. So we have a few ideas in mind right now. We put them in our roadmap, and we just want to quickly present them and ask for your feedback on these cards, votes, comments, and if these ideas are not really required, if maybe maybe these are not the first priority, please let us know, because that's incredibly helpful. And of course, vice versa, even more important. So the first thing we want to extend the agent to And that's one of the reasons why we actually originally started doing this. This is the providing live monitoring for Kubernetes resources through the agent. Basically, it's COS, object status, but live. You deploy it with the agent, and you can always open the tab and see all the resources on the cluster and their current status. So with the agent, this is potentially possible. So we have the card about it. This is QR code. If you scan it, you get to this card, and just let us know if this is something you would look into, or maybe like cause object status during the deployment time. It's actually more than enough. Another idea we have is what we discussed multiple times already today, is workers on Kubernetes. So what if we can use the agent not just to deploy to the current cluster where it's running, which will be possible right now, but use it as a dynamic worker pool and basically deploy to any other target from this Kubernetes cluster. Therefore, the cluster could be just a way to run scalable, auto-scalable workers without much struggle. So we can do that. This is on our consideration list. So again, let us know how important this is. Is it meaningful? Not? Maybe there are some aspects you'd like us to think about. And the third one is granular permissions to the agent. As Al mentioned, the agent can be installed within certain boundaries. But then, as soon as you do that, every task you execute on the agent will be executed on behalf of these boundaries, which, as far as we learned so far from interviews, which is maybe fine. However, sometimes maybe you want to have more granular permissions. Maybe you run multiple applications from different teams on the one cluster, or maybe you run different tenants or different environments, and maybe you want an extra protection. For example, you don't want project A impacting namespace of project B, or test environment namespace. Maybe you don't want this by accident if someone just put different namespace in the manifest. Maybe you don't want them to deploy it by accident in the, I don't know, development or test or staging namespace. So to do that, we can add another layer of protection, basically allowing people to match more granular service accounts with individual execution tasks. Basically, Octopus can understand if I'm deploying from project A to the test environment, just assign service account which allows access only to this particular namespace. So we can do that, but again, let us know if it makes sense. Maybe it's like too much and should be just done a bit later. And how you can try the agent. This is the agent current roadmap. So we meant to release it in the cloud end of this month. Depends on like how fast the instance will be updated, maybe early next month. And it will be in early access. If you add a comment or vote on this card, you'll be on the list, and I'll just update all the people who interested in the feature first and foremost. So you will have the update about the progress and we'll be able to use it. But also, we mentioned a few things today which I didn't have on my previous slides, like Windows nodes, listening mode, RBAC, and some other things. So please, if you have, I took notes, but I would really appreciate if you give us more details in the comments to this card. What else would you like to see to the agent? What other questions you have? And if it's okay, I maybe send emails to some of you replying to these messages, and maybe we can have a chat. So this is the early stage, and literally like this is where we can shape this feature and make it even better. Right. Yes, and finally, Joanna posted our Slack. We have a Kubernetes channel in our community Slack where we have discussions. If you don't really like using Roadmap for some reason, you can always join us there and send feedback on this presentation, on the webinar, or on the agent right in the Slack. And I'm there, Al is there, our team is there. We literally talk there every day with people. Thank you. That was really engaging.
Awesome stuff. That's awesome stuff, guys. Thank you very much. We really appreciate it. Thank you for all your questions. We had a ton of questions. Just to remind folks, we do have all of these items that Kit has mentioned here up on our roadmap at roadmap.octopus.com. If you want, you can continue to follow along with the webinars we have planned at octopus.com/webinars. And as Kit mentioned at the end there, you can join our Slack community, which is at /community. So /webinars/community, roadmap.octopus.com. Kit, Alastair, you guys made it. Well done. Congratulations. Sorry for a little sound snafu there, but if you have any other questions at all, feel free to reach us and let us know if you have any feedback on the Kubernetes agent. Really excited stuff, and we're looking forward to hearing from you regarding this new feature we've added. So on behalf of Alastair and Kit and all of us who are at Octopus Deploy, really appreciate you for your time and attention. We're going to end the stream now. Thanks again for attending, and we'll see you on the next one. Happy deployments, everyone.